Good day, my fellow scientists. Hope y'all are doing good. And we are back again at tackling maths and science with your favorite Sensei Mohab. So in today's lesson, I will be focusing on grade 12 physical science. It is past paper 2023, so I will be tackling it. 2023 Nsc. So now, this is a question on parallel resistors, circuit with parallel resistors. So now, if you are new to our channel, please press the subscribe button down there below, so that, and also that notification bell, so that every time we post a new lesson, you may know and you may be updated. And again, if you have any inquiries, if you want me to be your personal tutor, you can hit me up at 081 537 9527. So now let's begin. So now the question says a battery with an unknown resistor with an unknown EMF E and unknown internal resistance R is connected to three resistors: a resistor, a high resistance voltmeter, two switches, and two ammeters of negligible resistance as shown below. So now this is our battery, our cell. Here we have that small r which is for the internal resistance. This is for the battery. We do not know the EMF. So now we know that current goes that way from the positive to the negative terminal, and this is our IT. And here, since it's in parallel, our current will divide. Other one will go through S2, the other one will go down through S1, and also those two resistors. So now we know that in series that these two are in series to each other, and the same current A 1,5 it passes through these two resistors. Okay, so now let's start with the first question. So now first question says state Ohm's law in words. So Ohm's law in words, the reason why they say Ohm's law in words is that they know that most students will opt to do it in a form of an equation. So that's why it is best for you to follow instructions. So number one, Ohm's law in words. Ohm's law states that the potential difference, I'm just gonna write it in PD, which is the potential difference, is directly proportional to the current. The potential difference of a conductor, you should state that of a conductor, because we are dealing with conductors, is directly proportional to the current of the same conductor, of that conductor, provided which is common or constant. Very good. Temperature is constant. Temperature is constant. Okay, so now this is the answer of question 1. State Ohm's law in words. Now you don't have to worry too much about definitions and stuff. because you can use what is in the exam guideline to write this in like this in simple terms. And please do not try to use these definitions from your textbooks, which they may differ, so that this one comes from the exam guideline. It is straight to the point, so try to at least use this at all times. So now question 2 says both switches S1 and S2, S1 and S2 are now closed. So which means if they are now closed, that now we are going to follow this resistance parallel, which means the current is going to divide, is going to branch out. So now A1 reads 1.5 amperes. So now A1 reads 1.5 amperes. We know that if this one reads 1.5, this one may read, let's say, X, and this total one, it will read X plus this thing. Okay, so now let's tackle the question. It says calculate the reading on voltmeter. Voltmeter, which one? This one. So now what do we know about resistors in parallel? One thing we know is that the V parallel is the same. So now, which means the same, if now two resistors, I'm gonna draw it in this way, in this manner, so that I may indicate which ones are parallel to each other. Now, most students do a mistake here. So now, when it comes to here, when you have three resistors, just notice that these two are in series to each other because the same amount of current passes through them. So now we're going to add this ones. They're going to give us 2 plus 5, which is 7 ohms. So which means the 3 ohm resistor is parallel to the 7 ohm resistor. 3 ohm and 7 ohm. They are both parallel to each other. This is not parallel to this. This is not parallel to this. Both of them, both these ones are parallel to this one. So don't make that mistake of doing that this one is parallel to this and this one is in series. Don't do that. Okay? Whenever you are given two resistors and down at the second root and at the first root you have what, just know that because the same amount of current passes through them, which means they're in series to each other, we can add them, and then we say the sum of those two resistors is parallel to this one resistor. Okay, so now we know another thing, that now if now we have this resistor 1 and this resistor 3 and resistor with 7 ohms are parallel to each other, which means that the voltage will be the same. Voltage that passes through here will be the same voltage that passes through here. So which means now we can find the voltage because we have our current. So now let's note down everything we have. We have our current A1. Okay, I'm just gonna, let me do A2. It's 1.5 amperes. And we have our R. We gonna use this one since it's parallel to the 3 ohm resistor, and the voltmeter is connected across the 3 ohm resistor. Because if you were to do only for this and only for this, you can see that they are not parallel to each other. They're doing this triangle shape. Okay, so now 7 ohm resistor, and we have to find our voltage. So now our voltage, we know V, it is equals to I times R, current multiplied by resistance, which is, let me do R2, and it's 1,5 multiplied by 7. 1,5 multiplied by 7. Our answer will give us 10,5 volts. So now 10,5 volts, it's the current across this and this. I'm here, I just added my own voltmeter. 10,5 it's the same because we know that current, or sorry, voltage is the same in parallel resistors. So now let's deal with the second question. It says calculate the reading on A2, ammeter A2. Which one is it? This one. So now remember that the current from here, from inside the battery, it's gonna come out from inside the battery, flow from inside the battery, which is the total current. Then the total current, just like that. When it reaches here, there's a node or a node. Yeah. Then it will branch out. Some of it will go there, some of it will go and then with this route and with this route. So this route we call it I1, which is for the first current in the first passage, and this one we call it I2, the current, because of it is the second current in the second passage. So now they're gonna meet up again and connect again and join again as the total current, which is just A1 plus A2. I1 plus I2, then they're gonna go back to the second again and again and again. It is gonna be a cycle just like that. So which means that the reading on A2, it will be the total current. So now, how do we find the total current? We can find the total current in this way. Total current using A1 plus A2, which means we have to find the current that passes through here. So let's try tackling it. So I1 is V over R3, this one. So now let me just say R1, but it's this one. So the voltmeter reading here reads 10,5. So now it's 10,5 over 3. It's gonna give us the 3,5 amperes. Therefore, the total current is 1,5 plus 0, 3,5, which will give us 5 amperes, which is the total current from here. So now, some of y'all may try to use this. It is still acceptable. So, since now you know that we have the V parallel, and we can just do it like this and be like, okay, so now we have our V parallel. So now we must find our R parallel, and we just gonna use the total R parallel and the total current and also the total voltage, which is the external voltage. You understand? So now we know that we must find our R parallel. So our R parallel, note that we will use these ones. These ones are no longer applicable unless they ask a question on specifically on this two, on each of them. Maybe they ask you that find the voltage on A2. We know that since they're in series, then now in series voltage is divided. So now we know that this one will have the bigger share, this one will have the smaller share. Only in that case will we deal with them separately. But for now, we're focusing and we'll be using this one. So now R parallel R1 plus R2, it's R parallel R1, it's 3 plus R2, it's 7. 1 over 3 plus 1 over 7. Sorry, let me, yeah. It's gonna give us 10 over 21. And we know that we just gonna use this, the reciprocal or the inverse of it is gonna be 21 divided by 1. 21 divided by 10, which is 2,1 ohms, which is the total resistance. So now total R parallel, or the external resistance, it's 2,1 ohms, which is 2,1 ohms. And we have the I total, which is 5 amperes. So we can just use all our totals of the external circuits, and it's gonna be since we are solving that, so we're gonna use this and we're gonna use this, our voltmeter reading, since it's the same in parallel. So we know it's 10,5 volts. So we're gonna do like this. It's V over R. So it's V parallel. It's the external voltage and also the external resistance, which is 10,5 divided by 2,1. Our final answer, it's 5 amperes. It's our final answer. So now let's go to the next question. Calculate the power dissipated in the 3 ohm resistor. So now, this one's supposed to be 2, this one's supposed to be 1. 1.8.2.1. So now this 2.3, it's the power depleted. So we know that the power, it's V squared over R. So the resistor is this one, and we are still gonna use the same voltmeter reading, 10,5 squared all over 3. So divided by 3 is gonna give us 36,75 watts. So now let's continue. S1 switch is now opened while S2 remains closed. The reading on the ammeter A2 is now 3.6. So I'm just gonna do this. So since now S1 is now opened, it's not opened, so therefore we're gonna only be dealing with this one. Since the current will pass through here, will flow through here and here, so now this route is no longer applicable, but the voltage may be affected, but it is still the same. So now let's try tackling it. So now kindly note that when we are looking for the EMF, we're gonna use V external plus V lost, which V external it's I total multiplied by R external, and this is I total multiplied by R, which is the small r, which is for the internal resistance. So now, but here we are looking for two things. We do not have this one here, we do not have this one here. So what's the best method? Very good. We can use this thing, we can tackle this by using simultaneous equation. You remember that those questions in math whereby you have to solve for x and y, and you are given only two equations or three equations, and you must solve for x and y. So it's basically the same thing. So now I'm gonna use this. So now, first of all, they say switch S1 is now opened while S2 remains closed. The ammeter reading on A2 is now 3.4. So now, for the first one, we're gonna say closed. I'm just gonna do closed. So we know that if our A2, this is 3.4 amperes, which means that the total current is 3.4 amperes. So which relates because of we know that the current has now decreased, because now the resistance has increased now, because remember, whenever we were doing this R parallel, it gave us 2.1, but right now the R external will be only the resistor 3, which means that the resistance increases, so that's why the current decreases. So now for the closed one, it's 3.4 amperes, and the R external is 3 plus 3.64, which is the total current, and R, we don't know it. So now this is we're gonna use this to find our first equation. So now for the second equation, the opened one, this is the one when we were dealing with this, closed, and no, let me change this and just write, sorry for that, opened S1 and closed S1 and S2. So you can remember that S1 opened, it's this one whereby the ammeter reading decreased. So now E is equals to, sorry, it's 5 here. You remember the one we solved recently? You remember? It's 5. So 5 multiplied by 2 comma 1, which was our, very good, it was our R parallel, the total R parallel, this one. So plus 5 multiplied by R. So now you can see that both of these things are equal to E, which is the EMF. So we can just equate them. We equate equation 1 and equation 2, which is 3,6. Let's just find the answer. It's 3,64 multiplied by 3. It's gonna give us 10,92 plus 3,64 R. And this one is gonna give us 10,5 plus 5R. So we're just equating both equations. So it's 10,92 plus 3,64R. It's equals to 10.5 plus 5R. So now solve for X algebra. Find the like terms. This and this are the like terms, and we move the like terms to the same side, which we choose that side. Oh, and also this one and this one are also like terms. So now it's 10.92 minus 10.5 is equals to 5R multiplied by 3.4R. So this is minus 10.5. It's gonna give us 0.42 equals to 5 minus 3.64. It's 1.36 R. Then we divide both sides by 1.36. Divide also here by 1.36. Divided by the answer, it's our R, the internal resistance, will give us 0.308. Let's just round it off. It's 0.31. So, but then rounded off it's 0.31. But for now, let's just not round it off and just, whereby when we will be calculating, we'll just use this one so that it may not affect our answer. So now we have find our R, but we are not yet done because we need to find the EMF of the battery. When we must find the EMF of the battery when S1 is now opened. So which means when S1 is now opened as this one, we're gonna still use it. And remember, R remains the same because it's the same battery. So the internal resistance remains the same, even though whatever is in the external circuit may change. The internal resistance remains the same because it's the same battery. E equals to I times R external plus I times R. It's 10.42 plus 3.64 multiplied by this one, and our final answer plus 10.92. It's 12.04 volts. if they say you must round it off to a whole number, we just gonna put it as 12 volts. So now to the last and final question. It says switch S2 is now opened while S1 is now closed, which means S1 is closed now, S2 is opened, which means we're gonna only be using this route, the one that I'm using with the green highlighter. We're gonna be only using that route, so which means this purple route is no longer working. We're not gonna use it for this question. So S2 is now opened and S1 is now closed. How does the voltmeter reading changes? So now remember, the voltmeter reading will increase. Why? So remember that here, when we using both, our external resistance was 2.1. So when we only used this one, it was 3, the R external. So now, how much will be our R external? Our R external will be this added to this, since it's gonna be circuit that looks similar to this circuit in series. So which means our R series is the total external resistance. So now, which means now our external resistance increases. So now our current will decrease. And also, voltmeter reading, will it decrease or not? So now our voltmeter reading will, so now I'm just gonna use this because of, seems like this greenish one, it's not doing its work. So now our resistor will increase. How? So now remember, so let's use this equation. Okay, yeah, let's use this equation. So remember that V lost, whenever our resistor increases, therefore this will also increase. It's the same. This will increase and also this will increase. So that's how we tackle it. That, for example, let's say from being 3, it's now 7. So if it's 3.63 multiplied by 7, you can see that it's now 25, the external voltage, which means that the voltmeter reading is gonna increase, because now remember that the same voltage that is here will be the same voltage that is here, so it's gonna be more because the external resistance is increasing. So that's it for today. So I really had a blast, really had a good time tackling this with you. And again, if you have not subscribed to our channel, please do the right thing, brothers and sisters. And for more inquiries, if you want me to be your personal tutor, all my details and information are in the bio. So that's it for today, and enjoy the rest of your weekend. Bye bye. Shap shap.